Imagine an end user, an operator or developer, or general cloud practitioner who requires a new compute resource allocated. More specifically, the end user needs a web server to confirm the function of a simple startup script. From an ideal point of view, to build a new resource, the end user needs access to the governing network and the standard guidelines inherited from its parent organization. In other words, the new resource requires a global network, a local subnet, a firewall rule, and a compute resource to test the procedure. In some cases, that may indicate a full stack deployment or just subsequent parts into an existing environment. Terraform Enterprise helps you create independent modules that can manage the technical association, service procurement, and infrastructure build for all of these components in an orderly fashion. In this example, we are showing you 4 independent modules to fulfill the backbone functions to promote a self-service model for the end users. The availability of a self-service module means that the end users do not write code but consume vetted deployment recipes provided by the infrastructure team. Those recipes include best practices, policies, and rules which guide the end users when they procure new infrastructure. Instead of writing code, the end users are responsible for providing subject information such as names, descriptions, feature flags, and values to create new resources. In this example, the end user would have to provide a name for the new VPC network, a conditional true or false statement to confirm or deny the auto-creation delegate subnetwork, and a description for a new VPC network. In this demo, we advertise the required module components to build a complete stack. But it must be clear that not all end users need to build them from the ground up. Terraform Enterprise manages the overlap of existing infrastructure against new resources and coordinates according to the known state of the target environment. In the Terraform Enterprise user interface, you can add modules by referencing your preferred VCS. In this practical example, we have configured a security integration with GitHub. Adding the modules is a matter of browsing the existing VCS repository and then publishing the modules privately. Notice that in the definition of the VPC network module, there are matching input requirements for the end users. In this case, only the VPC network name is a required input, as the other two have defaulted values defined in the module configuration. Remember, end users do not write code, and instead, they are responsible for providing the appropriate information to facilitate the environment build. Once the modules are configured, we use the configuration designer to combine the modules and fulfill the requirements of the end user request. In this example, we build the entire stack, which includes a brand new VPC network, a subnetwork, a firewall rule, and a virtual machine. However, we must emphasize, in a real-life scenario, you may only need a piece of the stack to fulfill the end-user requirement. Typically, you may delegate responsibilities to using teams in Terraform. If your end user is part of a test team, they may already fall into a default VCP network, with a designated private subnet which, by the way, may contain defaulted firewall rules. So let's build a new deployment configuration to build a new stack. Notice that we can combine different versions between the modules to match specific feature functions or to maintain compatibility. We use VCS tagging to maintain versions of the module's code. Okay, you have a variety of choices to fill in the values of the variables in the module's form, but you need to complete all of the required variables in the modules to generate the final configuration code. In some cases, some of the information may not be immediately apparent within the context of the module alone. In this example, a new network subnet references an existing VPC network. In such cases, you may refer to the output from other modules. So, we use a special referential notation to populate the VPC network name and the value derives from the module network. This referential model allows you to use the output from other modules to populate inferred values. After all, the network subnet needs to be activated inside of a known VPC network. This type of nesting is an excellent example of a best practice enforced by an infrastructure team and hidden from the self-service consumers. In other cases, we can assign a deferred flag to a required variable. Then we assume that the values from the variables already exist as part of the final code. In this example, our workspace contains some predefined variables with values, which are consumed by the final code of this exercise. In other words, the final configuration can securely obtain the defaulted values directly from the Terraform Enterprise workspace without exposing the default values for the variables. With the final auto-generated code, we have a final recipe for the self-service product that your end users will consume. That final product resides in a private VCS repository securely integrated to a Terraform Enterprise workspace. In this example, we have the GCP_infrastructure workspace in the Terraform Enterprise deployment. And we have a corresponding VCS repository in GitHub. Our repository contains 3 configuration files. Main.tf contains the GCP provider. Modules.tf includes the gluten-free, free-range, newly generated code, and Outputs.tf indicates the essential information returned to the end user. Okay, so we copy the new code into the modules.tf file, and then we update our repository. Oops, we need to save our main file as well, just because I like to keep dates in the releases. Okay, with an update to our VCS repository, we expect that the VCS change triggers a planned in Terraform Enterprise. In the user interface, we observe the planned deliverables and have a chance to review the results. In this workspace, we also have configured the GCP credentials and the GCP project, where we intend to land this new set of resources. Okay, before we run the final job, let's prepare our intended target environment. Remember, we are expecting 4 new resources. 1, a VPC network. 2, a network subnet. 3, a firewall rule. And 4, a new virtual machine. Finally, once we have clicked on the Apply button, we navigate to the GCP console page and we confirm the existence of 4 new resources. Here is the Tech Demo VPC network and the Tech Demo network subnet. Also, here is the Tech Demo allow firewall rule. And here's the Tech Demo new virtual machine. Oh, by the way, if you recall, the initial intent of the operator was to test the functional result of a simple starter script using a web server. In checking the final product, using the new virtual machine public IP address, we can see a successful test.